Nature's solution to climate change. Wherever whales, the largest living things on Earth, are found, so are populations of some of the smallest, phytoplankton. These microscopic creatures not only contribute at least 50% of all oxygen to our atmosphere, they do so by capturing about 37 billion metric tons of CO2, an estimated 40% of all CO2 produced. To put things in perspective, we calculate that this is equivalent to the amount of CO2 captured by 1.7 trillion trees. For Amazon forest's worth. Or 70 times the amount absorbed by all the trees in the US redwood national and state parks each year. More phytoplankton means more carbon capture. In recent years, scientists have discovered that whales have a multiplier effect of increasing phytoplankton production wherever they go. How? It turns out that whales' waste products contain exactly the substances, notably iron and nitrogen, phytoplankton need to grow. Whales bring minerals up to the ocean surface through their vertical movement, called the whale pump, and through their migration across oceans, called the whale conveyor belt. Preliminary modeling and estimates indicate that this fertilizing activity adds significantly to phytoplankton growth in the areas whales frequent. Despite the fact that nutrients are carried into the ocean through dust storms, river sediments, and upwelling from wind and waves, nitrogen and phosphorus remain scarce and limit the amount of phytoplankton that can bloom in warmer parts of the oceans. In colder regions, such as in the Southern Ocean, the limiting mineral tends to be iron. If more of these missing minerals became available in parts of the ocean where they are scarce, more phytoplankton could grow, potentially absorbing much more carbon than otherwise possible. Letting whales live. This is where the whales come in. If whales were allowed to return to their pre-whaling number of 4 to 5 million from slightly more than 1.3 million today, it could add significantly to the amount of phytoplankton in the oceans and to the carbon they capture each year. At a minimum, even a 1% increase in phytoplankton productivity, thanks to whale activity, would capture hundreds of millions of tons of additional CO2 a year, equivalent to the sudden appearance of 2 billion mature trees. Imagine the impact over the average lifespan of a whale, more than 60 years. To solve this international public goods problem, we must first ask: what is the monetary value of a whale? Proper valuation is warranted if we are to galvanize businesses and other stakeholders to save the whales by showing that the benefits of protecting them far exceed the cost. We estimate the value of an average great whale by determining today's value of the carbon sequestered by a whale over its lifetime, using scientific estimates of the amount whales contribute to carbon sequestration, the market price of carbon dioxide, and the financial technique of discounting. To this, we also add today's value of the whale's other economic contributions, such as fishery enhancement and ecotourism, over its lifetime. Our conservative estimates put the value of the average great whale, based on its various activities, at more than $2 million and easily over $1 trillion for the current stock of great whales.